We've looked at two set operations so far, union and intersection. Let's now look at a third operation called the difference operation. The difference between two sets A and B, denoted as A minus B, is the set of elements that are only in A but which are not in B. So from the set A, if you take away the elements that lie in B, the result that you are left with is the set A minus B. So if we have to depict this in the Venn diagram, let's say this is set A and this is set B. A minus B is the set of elements that lies in A but which don't lie in B. So from the set A, if you take away this region which has elements that are common to A and B, you are left with this region which has elements that lie in A and only in A, which don't lie in B. So this region is the set A minus B. So more formally we can say that A minus B is the set of all elements X such that X belongs to A and X does not belong to B. Now it should be obvious from this Venn diagram that if we take the set A minus B and we add back this region which is common to A and B and which we know is A intersection B, we will get the set A. We'll get back the set A. So these are the elements of A which don't belong to B. These are the elements of A which belong to B. And these are the elements which belong to A. So it's as if the elements that belong to A are partitioned into two parts, those that belong to B and those which don't belong to B. Now suppose A is the set of natural numbers 1, 2, 3, 4, 5, 6 and B is the set 2, 4, 6, 8. The set A minus B will be the set of elements that lie in A but which don't lie in B. So when we subtract B from A, we have to remove from A all those elements which lie in B. Now 2 belongs to A, so we'll have to subtract it out. 4 belongs to A, so we'll have to subtract it out. 6 belongs to A, we'll have to subtract it out. 8 does not belong to A, so we don't need to do anything for it. The elements that are left, 1, 3 and 5, will lie in the set corresponding to the difference of A and B. One other thing to note from the Venn diagram is that the set A minus B is not equal to the set B minus A. The set B minus A consists of all those elements which lie in B but which don't lie in A. So if we start from the set B and we subtract out the elements which lie in A, this shaded region will be what will remain, and this shaded region is the set B minus A. So we can say, similar to this equation, that the set B minus A unioned with the set A intersection B or B intersection A is the set B. So we can partition the elements of B into two parts, those which also lie in A and those which don't lie in the set A. And from this Venn diagram you can also state a more longer equation, which is that if you take the set A minus B, which is this blue shaded region, take the union of that set with A intersection B, which is the region that's common to A and B, and then also add in the elements from the set B minus A, the resulting set will be the set A union B. So the set A union B is composed of three parts. In the first part we have elements that lie only in A but not in B. In the third part we have the elements which lie only in B but not in A. And in the second part we have elements that are common to A and B. And these three sets are also disjoint. So if you take the intersection of any of these three sets with any of the other, the resulting intersection will be the empty set because they don't share any element in common. So for example, A minus B intersected with B minus A is the empty set. A minus B intersected with A intersection B is also the empty set. And B minus A intersected with A intersection B is also the empty set. So this set difference operation is actually analogous to the difference between two numbers in arithmetic, x minus y. We know, for example, that x minus y is not the same as y minus x in general. just as we saw that the set A minus B is not the same as the set B minus A. So the difference operator does not follow the commutative law in set theory. Just like there is no commutative law for the difference operation in arithmetic. We can also see that in this example, we have already calculated what A minus B is. It's the set 1, 3, 5. If we calculate the set B minus A, it will be the elements of B that are not found in A. So 2 is found in A, so we can remove it. 4 is found in A, we can remove that. 6 is also found in A, we can remove that. A is something that's unique to B. It's not found in the set A. So the set B minus A will be the singleton set composed just of the number 8. So you can see that these two sets are not the same. Just as we saw that in the Venn diagram as well. The blue shaded region is A minus B and the green shaded region is B minus A.